We were asked, and because there is actually discharge going in through the groundwater to Crocker Pond, to get a better handle on the environmental conditions that we see there. And so as part of the town's series of studies that we purchased, I guess, Ecologic looked at the features. You all knew that it was a groundwater-fed kettle, right? But you also knew that it was 28 feet deep, but we confirmed that. There's a mean depth of 15 feet. It's got 10 to the 5th cubic meters of volume of water. And the distance between the discharge site at Site 7, the discharge at Site 7, and the closest point at Crocker Pond is 1,860 feet. That's the distance. And so that needed to be determined. That's over a third of a mile. So we have some facts about Crocker Pond. This is probably the most studied pond in at least Falmouth, not Cape. And the reason this information was important to derive and to get straight and to get right is because the next important question is, what about phosphorus? Because phosphorus is a limiting nutrient in freshwater ponds. And so to get an answer to this question, the town directed GHD to do an environmental analysis, just like we were asked to. So GHD hired a company called Ecologic, who specializes in doing soil studies and soil analyses. And the approach they used was to take soil samples from borings. We took the borings at Thomas Landers Road. I saw Sue when we were out there. We took soil borings. We had real soil samples. They took it back to the lab and did what is called a total elemental analysis. That is, they looked at the soils and they figured out all the elements that are in it. Then they did a physical analysis. They looked at the texture, they looked at the porosity, they looked at a number of physical parameters. And from that, they decided what the mix of minerals were that would impact phosphorus absorption. That is, which minerals are going to bind the phosphorus and how much is there and how long is it going to be. And based on the elemental analysis they did and a number of assumptions that are legitimately very conservative, and I might as well list them for you. First assumption was, what is the soil prism? The soil prism is like the funnel or the filter for all the soil. How much soil is this phosphorus going to go through before it hits Crocker Pond? The depth from the bottom of Site 7 discharge beds to the groundwater is 70 feet. The distance that was used to calculate the soil prism was 40 feet. So 30 feet were left on the table. There was 30 feet less soil volume, 30 feet by the obvious, width of that prism, that was not used in any of their calculations. So 40 feet, not 70 feet, one conservative assumption. Aluminum and the minerals of aluminum, not phosphorus. So if you look at the elemental analysis, there's more iron. There's more iron than there is aluminum. But Ecologic chose only to use the minerals that are associated with aluminum to figure out the binding capacity. And the third conservative assumption is they took a look at all the aluminum compounds that could be minerals that could be in the soil, and they looked at the number of binding sites. So phosphorus is going to bind to something and then it's not going to move. And they only took 30% of it. So conservative assumptions. And based on those assumptions, and based on a look at the soils, they came up with a number. And their number is 100 years, minimum, of binding capacity before any phosphorus moves anywhere. So, the Water Quality Management Committee got that report. And they looked at it, and because none of us are soil scientists, although some of us feel like becoming one, Ron Swag, in fact, decided that it was a good idea to have a soil scientist take a look at the Ecologic report because we wanted to get another set of eyes on it. So he sent it to Murray McBride, who's a Cornell professor, and McBride came back with a set of comments that had to do with areas that he thought there was uncertainty in the Ecologic modeling approach and methodology. So the first thing the committee did was ship that right back off to Ecologic and say, answer these questions, they're important. And they did. Ecologic came back a few weeks later with a point-by-point answer to all of the concerns and observations that were made by McBride. I'm not going to get into a point-counterpoint, because that would take all night, and we don't have all night. But I think if I were to distill the comments made, it comes down to you need field data to verify a model. So in modeling, in math and in science, you have an analytical approach, but then you want to verify it with field data. And so that was sort of his main set of comments. And so now I'm going to talk a little bit about, okay, we have an ecologic model, we have an ecologic methodology. They've said 100 years. What do we have by way of field data that either confirms or refutes that analysis? And in Ecologic's response to comments, they cite a paper. And they cite a paper from USGS, and it's a paper that was done for a Schumann. I'm sure everyone here knows where a Schumann Pond is. I'm sure everyone here has heard of Mass Military Reservation. This is right up the road in East Falmouth, and it's in the glacial outwash area of Falmouth, just as Site 7 is glacial outwash material. They're both glacial outwash material. That's been confirmed. So what Ecologic says is there are comparable soils. You can normalize for distance. You can normalize for concentration of phosphorus that was loaded through MMR. It was 3 times the loading that we're talking about. And you will find that if you compare the travel time from the Ashumet plume to their analysis, you get confirmation. It was over 90 years when you normalize for the factors, and Ecologic said 100 years. So one piece of field data that substantiates the model. There's also in the McCobb, or prior to the McCobb work from USGS, USGS likes to model stuff, and they actually did a model of how long it takes phosphorus to move in these glacial outwash soils. So in 1996, they actually developed a model, and to confirm their model, they actually did these soil column experiments on the soils right up in East Falmouth. And it confirmed the time travel that they observed at Ashumet, which confirms, at a pretty basic level, the 100 years. And then we have a third set of data. We have field data from our wastewater treatment facility. So we have wells up and down our wastewater treatment facility because of the nitrogen problem. These wells were installed and are monitored as required by Mass DEP, and they're there to watch the wastewater flow. And so what we see when we look at the data from these wells is you have upstream wells and you have nitrogen levels, and you have downstream wells and you have much higher nitrogen levels. So it's pretty reasonable to assume that you're actually looking at the plume, and as you look at this, you see the nitrogen levels going up and up and up downstream and staying about the same upstream. Now, when you look at the phosphorus numbers, because for all the years that we've been looking at nitrogen, we've also been looking at phosphorus, and you look upstream and you look downstream, the numbers are consistent. For the most part, they stay under 0.2 milligrams per liter. And 0.2 milligrams per liter is actually background. It's reported by USGS as a background number for phosphorus in these kinds of soils. So there's some up and down in the data. There were a couple of years where the analytical laboratories changed, and there were a couple of spikes. But the interesting things about the spikes in the data is that the upstream well spiked. So you got a higher phosphorus number upstream than you had downstream. There is absolutely, and I've gone through this, the charts and the graphs, there is not any breakthrough happening after 30 years. We've been discharging at the wastewater treatment facility for 30 years. The nitrogen is clearly there. It is obvious that nitrogen is going and moving and heading downstream. And it's pretty clear that the phosphorus isn't moving at all. They're the same values. So there's some field evidence. And I think, and so I'm saying these things to say, we did an environmental analysis. We got field verification. There could certainly be additional tests done. You could take a soil sample, you could do an extraction, you could do a lot of different things. But the path is clear that we're not seeing a red flag in the analyses that we've done. In fact, we're seeing the opposite. So I've talked about nitrogen. I'm almost done. I've got 2 more slides, 3 more slides. There's a triumvirate. We've talked about the phosphorus, we've talked about the nitrogen, and now I'm going to talk a little bit about contaminants of emerging concern.